Hey, I'm Peter, and since I'm quite new in talks, I'm really nervous. Although I have some experience on stage. It was a different setup and a slightly different audience when I was playing on drums in the rock band. So today I would like to invite you to another nerve-wracking situation. Imagine that you are like Julia, starting a new position, and it seems a pretty awesome gig since they wanted someone who writes clean, testable, and maintainable code. I mean, I never seen a job posting asking for ugly spaghetti code, to be honest, but yeah, that's the case. So the very first day, got access to the code base, have a task to do some bug fixing, open your Xcode and ta-da, you can see a view controller like this. I mean, it implements everything, probably making a cappuccino as well. What actually it does, it downloads a song information from the iTunes REST API, where the term is breakpoint, and on the received results, put a filter on the artist name to contain Dempsey. Today, I show you how to apply solid principles as a guiding tool and the clean architecture as the target during the refactoring process to turn into clean, testable, and maintainable code. So, just talk about the solid thing. Just a quick recap on the solid principles. The single responsibility is it's all about doing one thing, right? The open close principles is the ability to extend the functionality of a module without modification of the existing code. We have the Liskov substitution principle. It's about the interchangeability. If we want to interchangeability in our code, we must define the contracts and implement them in the interchangeable parts. There is the interface segregation principle, which I will rename it for us protocol segregation. It's more obvious for us. But the gist is not to depend on what we are not using. And the last one is dependency inversion, which is actually a strict guide on the direction of the dependencies. So, a few words about the clean architecture. It is heavily influenced by the solid principles for sure. The circles are representing different areas or layers of the software. And further go inside, we are on a higher level of abstraction. The rule is that dependencies can point inwards, never outwards. The promise, and that's why I like it, that we should be independent from any framework, like UI, storage, networking, or reactive frameworks. And the business in the circle should know nothing about the external world. As you can see, the UI is also considered as the infrastructure, as well as the networking or the persistency storage. So let's try to dive into the code and outline the responsibilities, starting with the ones that looks familiar. So I wanted a very ugly code, and I was lucky to living in the age of the AI because it gave me the ugliest without hesitation and specifically asked for it. The view controller class and its extensions are related to the UI implementation. So that's one of the responsibilities in this class. We have the URL request, URL session inside the view controller implementation, which implies a different responsibility. As we saw it, they are on the other end on the spectrum of the clean architecture than the UI. So I would say it's part of the infrastructure, but should not be in the UI code. There is also persistency, probably for caching reasons, using the user defaults. As we saw, this is also the infrastructure layer thingy alongside with other persistency networks or frameworks like core data, sweet data, file manager, or keychain related persistency function. And even I would put the in-memory cache here. At the end, we have the main wheel, the domain or the business layer, and that's including the domain entities like the song structure and the use cases which are processing those entities. In our code is the filtering that holds the main functionality with the models of our app. Now we know about the different responsibilities on this code. One class. Let's start separating them, starting with the domain first. So you might say that, is it worth to put the filtering into the separate entity, like in the bottom, or using the same entity, like the song itself, like on the top? Well, this is the classical example of the bad separation of concern, when the entity and the different use cases codes are tightly coupled. So I'm a fan of total separation. So I have a separate struct with the strong data, purely the data, and the filter functions with the strong data parameter. A small note about the parameters, I just copied the original code, so that's why it's an array of the dictionary. The next is the open-closed principles. The idea behind this that we can have functionality added to our existing code without modifying the original behavior or the original code. So in Swift, we are quite lucky because we have the extensions, and they are really good tools to achieve this. To compare a song to another, for example, in a unit test, I require to conform to the song to the equitable protocol. And in order to save it into the user defaults, I had to conform to the encodable protocol. Usually I put those extensions next to the code, the respective code which is using them, but I can open it up anytime. So I'm like a cautious politician. I tried providing the least knowledge to the public. Another good trick for the open-close principle is to extract a given algorithm into an abstraction and inject it accordingly. We saw the filter function already. If I add the artist name as a parameter, the behavior of the internal logic is still the same, but we already opened up the possibility to extend the behavior of the filtering. So I can filter, for example, to Adrian Eves. Adding just one parameter in theory can open other possibilities, but if I can put even as a closure, it's quite similar. But now I have the closure itself that can be run and injected into that functions. Be aware, extracting all of the algorithm and logic out from your class to being open might not be a good idea, because you are ending up with something like a composer, which I will show you later. So now I'm happy with the business logic. Let's try to separate the remaining responsibilities. I created a separate entity called data manager, which is in charge of for loading from the network and also saving to the disk. Sneak peek, that was similarly good idea as asking AI to generate my code. The view controller now, the code is cleaner now. Well, for me, it's still ugly. Let's move the whole logic from here into a separate entity, let's say into a view model. For me, it seems it's doing a lot of things, not only one. Does it still have the single responsibility? Yes, because actually single responsibility principle says the module must have only one reason to change. What this code does is providing the order of steps to get the songs from the network, filter them, save them, and then create a view model. The reason to change, if we change the order. For example, before we hitting the network, we want to check the song is already saved in the cache or in the data store. At the moment, that's not just the flow change, but since we are depending on concrete implementations, those dependency changes or replacement can trigger change in that particular class too. Let's get rid of those hard dependencies. And before we're doing that, just want to point out that at the moment, the view model and its all dependencies now can be free use with any Apple platform-related UI framework. So basically, it's opening up, again, new possibilities. So talking about dependencies, dependency inversion or injection. So what's the relation between the inversion and the injection? Well, they are not the same. The inversion is the theory which defines that high-level code, like the inner circle of the clean architecture diagram, cannot depend on lower details. And the injection is an implementation that helps achieve the inversion. Usually the dependency injection is the holy grail of testability, but also can help us in other principles, like as we saw it in the open-close principles. Just a quick recap how different type of dependency injections looks like. Here we are injecting the song type here and making the receiver depending on that particular type. Usually the preferred way is via the initializer. Another could be via a variable, and the last case is via a function parameter. But be aware, the last one is quite tricky a little bit, and it still creates a dependency. So how we can see those dependencies is the dependency diagram. At the moment, we have that nice thingy, right? So at the moment, everything view model depends on everything except the view controller. So it has more reason to change than one. But the diagram is not really in line with the clean architecture, right? So I think the desired setup would like something like this. There are notable differences. I renamed the song filter to song provider and removed the JSON encoder since the functionality should be embedded into the infrastructure layer. Where I always struggle is that part where the data manager must depend on the use case and the entities. However, the solution is quite simple, and we call it protocols. So if a song data manager protocol is introduced in the song provider use case, literally in the same file that defines the contract, but the higher level implementation the song provider is expecting from a module that can serve as a data manager's class, it's solved. Although I have a problem here. If I ever need to separate the fetch from network and save to disk functions into a separate entity, I mean, one of each, I will be in trouble because both entities now would have an empty function. So the entity fetching from the network needs an empty implementation for saving to disk. And the same to disk implementation will have an empty implementation for the network fetch, or worst case, it's a fatal error calling implementation, which is a red flag. And this is where the interface protocol segregation comes into the picture. So the networking call and the saving call must be segregated from each other. So we need to have two protocols. We still can have one implementation, for example, in testing when we are injecting this, but the protocol level, they must be separated. And as I'm thinking though, if I want real flexibility and interchanging implementation, like writing to an in-memory NS cache and patching from there, this protocol won't fly anymore due to those names that implying the implementation details. And this is where the Liskov substitution should ring a bell. It was originally explained with subclasses and inheritance, but I personally not using inheritance on my own code, apart from the ones that Apple requires to be subclassed. So the interchangeability in our case is more about creating and naming contracts without implementation details, abstracting the fundamental behaviors to have interchangeable implementations. In our case, probably a load song and a save songs implementation like this would be much better. And thanks to the risk of substitution, if the song provider has a song loader injected, we could have several song loader implementations in place with different underlying implementations. They are completely interchangeable. So I can have an implementation for loading from the network or loading from the cache. Similarly, we could have different persistency capabilities based again on the underlying implementation, like saving in the file or saving in the cache. Okay, so now I have those, but what is going to bring those pieces together? And this is where the composer entity, which can build all of them together, comes into the place. Moreover, you can also easily compose together with different implementations. Basically, it spits out a view model based on the injected parts, and then view model can be used to compose for your specific platform view code. And as you can see, everything else can be packed into the Swift package as part of the code base modularization. Finally, if I move to the composer into the package, I can inject a spy for loading and saving functionality and assert date changes by driving the whole composition via the view model in my tests, in my unit tests. I hope I could show you a glimpse how the solid principles and the clean architecture can help you write more maintainable, testable, and clean code, which is also easy to extend to other Apple platforms and supporting your modularization. It's just up to you to practice them, make a good use of them in your code base. Thank you very much.